Okay, in this lesson we are going to look at area of triangles a bit more. In the last lesson we looked at calculating the area of a right angle triangle, and if you can remember we came across a formula that we could use, which was area equals a half times the base times the height. Area equals a half times b for base and height. Okay, so that was what we learned about right angle triangles. What we're going to look at is, well, what is there a rule that would work for all triangles? Because not all triangles are right angle triangles. And so on the screen here I've got three different triangles marked out in red. The question is, put them in order of size. Which triangle do you think is the largest area? Which do you think has got the next largest area? And which one do you think is the smallest area? Okay, because obviously they're all different in terms of how they look, and therefore the question is, can you tell by your eye which one is the biggest? I'll give you a moment for that. You can pause it if you want and try and order them 1, 2 and 3. Okay, what did you decide? Which one do you think has the biggest area, that of the red shape inside? Well, let's have a look. We know that for a right angled triangle, the area is a half times base times the height. Or we know also from use counting squares at the beginning of working out area that we can just count the number of squares. So let's just have a look. We've got inside here, we've got half of, so we've got a rectangle 1, 2, 3, 4, 5, 6 by 4. So there's 24 squares in there. So the area here is obviously going to be half of 24, which is 12. I'll put, let's just put boxes just now, okay? Because we're just counting really. I haven't used the formula. I could have used the formula to work out the area of this one here, but I didn't, okay? Let's look at this one here. It's difficult to know what fraction of the whole rectangle it is because it's not been evenly divided into like the first one. So what I'm going to do is I'm going to introduce another line from the top of the vertex here all the way down to here, okay? And what that does is it splits the big rectangle into two smaller ones, okay? You see how this, what we're going to see is this left-hand rectangle. And if you look at that rectangle there, do you notice that that red line goes from corner to corner? In other words, the red shaded part of that left-hand rectangle is exactly half of the box. So what I can do here is say that if there's 1, 2, 3, there's 12 boxes in that left-hand rectangle, the area of this part here has to be half of that, which is 6. Okay, so the area is 6 of that part. And then have a look at the right hand box. Well, it's exactly the same size. It's 3 along and 4 down. So there's 12 boxes in this half. And if I want to work out the area of the half of that rectangle, that's going to be 6 boxes. So in other words, the area is 12 boxes altogether because it's the two halves put together. So do you notice in actual fact that the area of this red triangle is the same as the area of the left hand one? But surely this one looks a bit different because it's the sides are all different lengths. There's nothing kind of regular about it. Does that mean that it's the same? Well, let's have a look at the doing the same idea. We're going to split it up into draw a line down from the top, and we're splitting it up into two rectangles. One is actually a little bit bigger than the other. So let's have a look. Get my highlighter and say, well, here's the left hand rectangle, okay? Do you notice again this sloping line, a diagonal, goes from corner to corner of the rectangle. So we know that the each section is half of the box. So see this shaded bit in here? It's going to be half of the area of the rectangle, which is 4. So a half of 4 is 2. It means that there's basically 2 boxes worth of area in that part of the triangle. So let's have a look at the right hand side, and we'll look at this rectangle here. Well, what size is it? It's 1, 2, 3, 4, 5 by 4, which is 20 boxes. And again, this line goes from corner to corner, so the right hand side of the triangle is half of the area. half of what? Well, 20 boxes. Half of 20 is 10, so this half is 10 boxes in area. And if you add 2 boxes and 10 boxes, you get 12 boxes. So what we've managed to discover is that all of these 3 triangles have the same area, and that's because, if you notice, they actually all fit within the same large rectangle. So it doesn't matter if the top of the rectangle is at the very left hand side to make a right angled triangle, or if you pull it along anywhere along the top, it will still have the same area. Okay. Now the important thing is that when we talk about the height of the triangle now, we're not always talking about the length of a side. So we always have to have this straight vertical line from the base. Sometimes it's dotted, and that's our new height. And that's why we don't call it length and breadth. That's why we call it height. So in other words, we're looking for any triangle, we're looking for a base and a height at right angles. Okay, so let's have a look at this. Before we do through that, I will remind you, we can write this down for all triangles. So yesterday, or the last lesson, we had a look at the idea that the formula worked for right angled triangles. We can say the area is equal to a half multiplied by the base multiplied by the height. So we're going to use that throughout all of our work today. Okay, so let's have a look at these. I'm going to set you out. Well, I'll do the first one with you, and then you can try the rest of them. Okay, so these are all triangles. They're not right angled triangles, but if you notice that we have an indication, the base is usually at the moment along the bottom. It's not always the case, but the height always goes straight up from that, and in most cases we've had to put in these dotted lines to say this is the vertical height. So what do? We start off with the formula, area equals a half times the base times the height. We then substitute in, as we did with the right angled triangles. So we've got 8 and 3 as our base and our height, and when we're working it out, most of the time it's easiest to try and do half of one of the numbers. So you can multiply 8 times 3 and then half it, but remember we were trying to do the halving it beforehand. So half of 8 is 4, still multiplied by 3, so our area is 12 units or centimetres, so our area will be square centimetres. Okay, so the first part of this lesson is we can apply the formula to triangles that are not right angled. It works for them all as long as we've got the right dimensions marked in. If you look at the ones at the end, number 5 and 6, do you notice that the dotted line is actually out of the triangle? It's because the vertex goes over the edge of the base. Okay, but it doesn't matter. But height is from the vertex, from the corner at the top right down to the level of the base. Doesn't have to touch the base there. Okay, so pause the video, try these other ones, and then I'll put the answers up so that you can correct your work. Okay, so pause it just now, draw out these diagrams. I want to see the diagrams drawn in, and then I want to see the area calculation beside them. Okay. Okay, so here's the answers to these that you should have got, so you can correct your work. Go back and check it if it's not right. Okay. So the next part to this wee activity is to remind you that we're now working with triangles and rectangles. So a couple of little problems to solve. It says the area of the triangle and the rectangle in this problem are equal. Find possible dimensions for the rectangle. Okay, so if we know the area is equal, the first thing we have to do is to actually work out what that area is. We've got information about our triangle on the left hand side, so I'm going to do this now. It's good sometimes when we've got more than one shape, and I'm going to do a wee area calculation here. We've got a couple of options. We can either number the shapes, like we'll call this shape 1 and shape 2, or you can use little kind of diagram symbols to represent the shape. So if I wanted to work out the area of a triangle, I could actually just do that and draw a wee triangle. Okay, so area with a wee triangle kind of down at the bottom means the area of the triangle, and it's kind of good so that I'm not just saying any old area. So area of the triangle is a half times the base times the height. We've got to juggle two formulas now. triangles and rectangles. So just make sure you use the right one. So it's a half times 8 multiplied by 6. Well, a half times 8 is 4, and 4 multiplied by 6 is 24. I'm just going to do that all in one go, which means that my area of the triangle is 24 square centimeters. It says find possible dimensions for the rectangle. Well, we'll need dimensions here and here, remembering that the area of a rectangle is not a half base times height, it's length multiplied by breadth. So we've got to put two numbers in here so that the answer is also 24 square centimeters. So remembering that we just need to find one number multiplied by another makes 24. There's a variety of answers that it could be. Can you think of what numbers could go there? Well, okay, it could be 12 times 2, or 3 times 8, or it could be 4 times 6, or 1 times 24. All of these are possible answers, so you can choose one. It just says find possible dimensions. It doesn't say find them all. So I'm just going to write in, I'll pick one, I'll be 8 centimeters and 3 centimeters. Okay, and I'll show that that's the case. I'll do you notice that I haven't just written in the answer. I've actually shown that I know why that's the right answer by using the formula. Okay, so that's a wee demonstration. What I'm going to do is I'm going to leave you with this little problem to solve. It says the area of the triangle, rectangle and square are all 36 square centimeters. Find possible dimensions for all three shapes. Okay, so I'm going to leave that with you. I'm not going to give you the answers. We can check on that another time. What you've got to do is to think now. It's a wee tricky one here because there's a half involved in the formula. But what I would like to see in your working, you're drawing all the shapes, I do want to see you showing, not just putting numbers in and thinking, I know that works. You're going to be demonstrating the fact that for the numbers that you choose, the formula holds. And remember, the area of a square is the same as an area of we usually just use length times breadth. You can use length times length because it's the same number. You're going to have the same number in there. So have a go at that, and we'll see how you get on with it. Okay, hopefully that's been useful. So the key issue here is that the area of any triangle works with the half times base times height formula. It doesn't have to be right angled, and that's good news. Hope that's been helpful.